Let's consider an example now. And I want to consider the example that you have seen probably in a workbook or you have seen before, but an example which is very common. Consider yourself in the setup of buying a computer. You go to a store, computer store, and you want to purchase a computer. So what's important is that we want to store the client or the customer purchasing information. So don't forget that when you go there and you're shopping initially, you go and get quotes. You get ideas about the prices. But when you are ready to buy, what do you actually do? The word is order. You place an order. So you can say that a customer, and to avoid working with the details of the attributes, I just would like to work here with just conceptually the ERD, and in this case I just do this, and I don't have to make a big long box because I'm not dealing with the attributes. So a customer places an order. A customer places an order. Of course, when you place an order, does it include any details for the computer? No. The order itself identifies a transaction that's happening. Don't forget that when you buy a computer, you're given an invoice describing the details. That's data and information that has been processed by the database. But when we're talking about design, we have to structure it. We have to break it down into smaller pieces. So the first thing you do, the customer places an order. That represents a process in a business. But then the order contains items. This defines, the items defines what's in that order. So let's take a look at this and analyze it a little bit further. The next thing we have to do is we have to see the relationships, and we'll take a look at it from a logical perspective. Can one customer, that's the question, place many orders? Can one customer place many orders? Of course, because you can go and buy 200 computers or parts or components. So we accept it. Can one order be placed by many customers? Just for argument's sake here. Think about it. A lot of you might jump and say, yes. Think about it 2 seconds. We're talking about here an order, a purchase order. An order is unique to the customer that has placed it. It never repeats ever. So we reject this. So the relationship is one to many. One to many. If you don't get it, think about it. We do the same thing here. This one is done. Can one order have more or many items? In other words, in one order, can you buy a printer and a monitor and a CPU and a motherboard? Can you have many items or products in the same order? Well, the question is yes. The answer is yes. Can one item be in many orders? What does this mean? It means that if I buy a monitor, can you also buy the exact same monitor? Don't forget, I place an order, you place a completely different order. can your order have the exact monitor that I'm buying? And the answer is yes. So the relationship is many to many. And we are done with this. I will erase this part for 2 seconds because I need to use that space to explain further the example. Now let's take a look, before I go further into specifying the ERD and finish up all the requirements of an ERD, let's take a look 2 seconds of what is in that box. What is this box? It's an entity. Fine. Entity represents information. Fine. Inside, you should see that there's like a little door. If you open that door, what do you see inside? You should be able to see attributes. Fine. Such as customer ID, customer name, customer address, customer gender, and so on and so forth. And if you look at the table itself in Access, let's think about Access. If you look at Access itself, Access, to represent that entity, will have to create a table called customer, where the fields in that table in Access are equal to the attributes in that entity. If you didn't get it, I don't have to repeat it because you can just go back and run it again. See what I said. I can repeat myself many times technologically on your computer without me actually doing it physically. So, this in Access represents a table where the attributes inside are actually fields. So in effect, we see a table structure that could be populated with many, many customers. What does this mean? It means that this, in effect, is a list, a table giving you a list of customers. If a customer ID is 1, 2, 3, 4, in that table, how many times would you see that customer? In how many records, if we're talking about Access? How many records would contain the customer 1, 2, 3, 4? And the answer is 1. 1 and only 1. Because you have a list of your customers and you have the same customer. No matter how many orders they place, it's the same customer. Now let's take a look at order. And let's think about it again. This is an entity that represents information. What kind of information it represents? It represents the order information that a customer has placed. If you look at the door here and you open it, you'll find attributes. Attributes such as what? Attributes such as order ID, order date, order time. You timestamp the order or the event. Now, you expect in Access to see a table called order, in this case and not customer, where the fields in that table are the attributes that we identified behind that door for order. Again, order ID, order date, order time, order shipping address, order billing address, and so on. In effect, this order is a list of orders, not customers. Now, if I change this and I ask you the question, for order ID number 5, how many times will it appear in that table in Access? And the answer is 1. Pay attention now. If I am to relate both of these together, how do I relate them? To relate them, I have to add in that table I have to add customer ID. Let's take a look here, 2 seconds also. Let me review this relationship for the example. Customer is customer ID. I'm going to write small. I don't know if you can see them. Customer name, customer gender, you get the point. That's the table in Access. And I can have 1, 2, 3, 4, 5, let's say customers. Names G, A, B, C, D, gender male, male, female, male, female. And that's called the customer. Order is another table in Access, and that's called order with columns. We can have order ID, order date, I just put OD, and order time, order shipping address, let's say order shipping address, order billing address. So here I have orders 1, 2, 3, 4. Now, let's take a look at these two tables that are in Access. How do I know that whatever here there is, okay? How do I know who placed order number 2? How do I know? This is Access. This is the final product. After my ERD, I go to Access. How do I know who placed the order? Who placed order number 2? There's no way from this table to know. Remember in the ERD where I told you how you take the primary key from one entity and you put it in the other entity, and that's how you call it foreign key? That's exactly what's happening here. I have to take this CID and add it to this table, and I would call it CID. And then I can say order number 1 was placed by customer number 1. Order number 2 was placed by customer number 1. Order number 3 was placed by customer number 5. And 4 is by customer number 2. So now I related this to this via the customer ID. The customer ID in customer is a primary key. The customer ID in the order entity is a foreign key. That's a foreign key because it's foreign. It doesn't belong here. It comes from another country, the customer country. This is the customer ID, belongs to the customer entity, and so it's a primary key. And that's how you relate the two tables together. We don't show this in the entity relationship diagram. We show it in the next step, which we call the record structure diagram, and which I will explain later on. Now be careful. As a rule of thumb, if you don't understand it contextually and logically, always in a one-to-many relationship, you always take the primary key from, that's not a from, take the primary key from the one side of the relationship and add it to the many side, to the entity on the many side of the relationship, which means that I take the primary key from the one side of the relationship and I add it to the entity in the many side of the relationship. This video is becoming long, so I'll stop here and I'll make another video to deal with the order items relationship. Well, I'm sure here that this is getting heavy stuff and you guys are getting very tired, so I put some background music for you. Hopefully it'll soothe you down. Okay, now let's take a look at the relationship. Order has items. It's a many-to-many relationship, and we have looked into the relationship before where one order can have many items and an item can be found in many orders. So what does this mean? Let's take a look again, just like we did with the customer places order. Let's take a look at what this means in Access. We all have worked with Access or even Excel. This is a table which contains order ID, order shipping address, order date, at least. Okay? And we saw also that it needs order, customer, where it needs customer ID. to do the relationship with the customer entity. And that is a table which contains all the orders. 1, 2, 3, 4, 5. Now, of course, shipping address, whatever you want. Date, it can be the 10th, the 11th, the 11th, the 11th, the 11th. The 11th was a very lucrative day. Customer ID 11135. These are the customers who place those orders. Items is what? Items could include item ID. Item ID could include item description. Could include, let's say like this. Could include items on hand, or we could say items in inventory, okay, and so on. And this is where we go. So in effect, items, this is the order table, and this is the items table. In effect, item ID could be 1, 2, 3, 4 if we start sequentially. This could be a motherboard. This could be a CPU. This could be a monitor, some monitor, and so on. Here, for argument's sake, let's say RAM. In inventory, item in inventory, you could have 5, 3, 1, 100. It doesn't matter. Now, how do we relate those two together? We know there's an order. Let's take, for example, order number 2. How do we know what is in order number 2? What are the items? We don't know. There's nowhere here that tells us. Just know one thing, that if we do the same thing as we did before, customer places an order, we take the primary key from the entity of the one side of the relationship and put it in the entity of the many side of the relationship, then where's the one side of the relationship here? We have a problem. As a rule of thumb, take it this way. In a many-to-many relationship, you need a third table in between. And that third table in between, okay, is called the correlation table or the associative table. Associative table, which correlate or associate this table with this table. How do we do it? It is the relationship itself becomes a table. And since it becomes a table, then we treat it as an entity. And if we treat it as an entity, then we put a square around it. So as a rule of thumb, whenever you see a many-to-many relationship, the relationship has a square around it. And since it's an entity, then it could have attributes. It has the legal right to contain attributes. So in this case, that table would look like, it's called the has table, and it would look like as has ID. You can put an ID. It has the order ID in it, and it has the item ID in it, and it could have the quantity in it. Quantity of what? Of the products bought. So in this case, this has table identifies what items are found in which order and how many of them. So if we take order ID 2, 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 1, 2, 3, 4, because this is the has ID in this case, it's optional, we don't need it, but you can have it. But in order ID, item ID, we bought one motherboard, that's item ID is one motherboard. We bought RAM, which is 4. We bought 4 pieces of RAM, or for argument's sake, we bought 2 pieces of RAM. We bought item ID 3. We bought 1 monitor. And I bought a dual CPU computer, so CPU is 1 and 2 of them. So now, I know that order ID is related to here. Item ID is related to here. So item ID is related to order ID via the has. So in this case, we'll ask the same question. We'll ask the question. This is a CPU, sorry. Can an item ID, can an item be found in many rows in the has table? Yes. And can the order ID be found in many times in the has table? And the answer is yes. So in effect, when you go to access, the relationship will be 1 to many and 1 to many. Don't forget that this is a table. So you have to imagine that there's a little relationship here, little relationship here. So this many-to-many relationship ends up to be 2 relationships, 1 to many on each one. In ERD, we represent it with a box. We don't do it this way. We don't break it down. But we represent it as many-to-many. Think about it. What you should do, take that example and actually go and do it in Access and do the relationship, and you will see how it will work.